Today we will be discussing about this third assembly, mm, the assembly of a flange joint, flanged pipe joint. So this flanged pipe joint or flange joint, it is also used like the quarter joint and socket pivot joint only. This is like most of the time whenever we are having different pipe section which are joined together at that time connection mm, at the intersection region or at the connection region to connect two different pipes we'll be having this flangeoid. So mainly this will be the one of the flange which is attached to one pipe or which is adhered to another one pipe, and we'll be having another flange, and also we'll be having another flange pipe assembly. Those two pipes and flange joints uh, assemblies, they'll be joined together with the help of this gasket and with the help of nut and bolt. Okay, so the space in between or the region in between two flanges, they'll be fixed with the gasket so that to minimize the vibration which will be happening when the movement of the fluid will be there in the pipes, and and also to give the rigid support, or to give like act to act like a static seal, so that there should not be any leakage in between these two pipes, to prevent those leakages and uh, to provide smooth surface to the movement of the oil or to movement of the fluid. This gasket will be provided in between these two flanges. So here we'll be having one flange joint, then in between them we'll be having our gasket, then another the same. If it is mirrored, here another flange will be kept over here, and to the end of this we'll be having this pipes, and here also we'll be having another pipe. So these two pipes will be kept over here, and after that we'll be having our nut and bolts which will be joining these two flanges. With that we'll be having our flange joint. So in this flange joint, first we are going to create a flange which is having this much dimension, and it is made up of cast iron. Okay, so it will be called twice in the assembly environment, but here we'll be creating it only once, then we'll be calling it twice. So this is the dimension of this entire thing, entire this flange. It is given like this. The total dimension from one end to another end is 112 diameter. Then the inner seating arrangement or inner protrusion of this flange, which is uh, which facilitates the support for the pipe, that will be having diameter of 68 mm. Okay, this will be having 68 mm. Then after that, this will be having the protrusion will be having small protrusion will be having 6 mm thickness, and 12 mm thickness will be for that total flange bottom. And also this will be having 11 mm hole inside this flange, And to see how many holes are there, to check that, we should go over here in the previous diagram, and we have to see that in this 11 mm hole, we'll be placing our M9 bolts. So when we are placing these bolts over here in this 11 mm hole, how many bolts are placed inside this? By knowing that, we could know that how many holes are there in this flange. So here we are using M9 bolt which are 4, and also we are having nut which are 4. That means there are 4 holes. Okay, there are 4 holes. When we are knowing that it is 4 hole, at that time we should know that this is having this is having equidistant from each other. So this will be having 90-degree inclination, or it will be placed in a square shape, okay, in a circular manner. From one hole to another hole, it will be having angle of 90 degree. We won't be knowing the dimension, but we'll be knowing the angle. So here, if I take front view of this, if I draw it like this, then the first diagram or first hole, if it is kept over here, then another hole will be kept over here, then another hole will be on the horizontal diameter. So from these two things, if we join over here, this angle will be 90 degree. This will be 90 degree, or this will be perpendicular with each other. So with that, we'll come to know that if there are 4, then it will be 90 degree. If there are 6, like if 6 bolts are there, or if 6 nuts are there, then it will be 360 divided by 6. So that will be 60 degree. Here it is 90 degree because it is 360 divided by 4, which is 90 degree. If it is 6 holes, then it is 60 degree. Then after that, we should see that there is a hole of 60 in this one, in this gasket, and also these pipes, they are having the dimension of 50 60 mm, and there is a thread of M56. There is a thread of M56, and that value of the thread will be known over here, which is 12 plus 6. So total 18 mm will be there. So here also we have to provide a hole. We have to provide a hole of 60 mm, and also we have to place this M56 mm thread. So now we'll be moving to solid edge software. So we'll be creating a solid part using this solid part uh, option. And after that, we have to create this flange joint. Either you can create it with the help of uh, revolved protrusion, or you can create it with the help of protrusion. So I'll be creating it with the help of protrusion. First I'll be taking this right profile plane, okay, or you can take the front view also, but front view should be like this. So I'll be selecting this right profile plane only, and I'll be selecting this protrusion command. So once I select this protrusion command, then it will be asking what you want to create. So here I'll be creating a line which is having the circle which is having 112 diameter. This is one method I'm teaching, okay, first method. Then after that, this will be having 12 mm dimension. So I'll be selecting the symmetric extent, and after that I'll be selecting 12 mm. Then after that I'll be clicking on this finish option. So once this flange is created, this bottom of flange or the land of this flange is created, now the upper protrusion or seating should be created. So for that, what we'll be creating, I'll be selecting once again the protrusion itself, and here I'll be selecting the rear face of this one. On this I'll be creating a circle which is having 68 mm, 68 mm. This will be having 6 mm dimension. Okay, it will be having 6 mm dimension, and I'll be keeping it in diametric mode. So 6 mm dimension is created. So now I'll be going to this once again protrusion, and I'll create this with the edit definition. And here I'll be selecting, instead of uh, symmetric extent, I'll be selecting it as non-symmetric extent. Because when we are using this, when I call this in assembly environment, at that time we should see that both the flanges should be adhere to each other, and it should be called upon that particular reference plane only, which is right profile plane. So for that reason, I am be selecting this with the non-symmetric extent, and I'll be keeping it as 12 mm only. So I will naming it as protrusion 1 only. Then after that, in this extruded protrusion 1, we'll be creating another model. If I select it, then the software will be showing two extend steps. So I have to create 6 and 6. So instead of that, I will be going with this normal protrusion method only. And here I'll be going with this another protrusion which is having 68 mm diameter, and also this will be having distance of 6 mm. Okay, 6 mm dimension will be placed over here. Then after this, I have to create a hole of 11 mm. So I'll be going with this 11, that hole option, and after that I'll be selecting this face over here, and here I'll be placing a hole of simple hole which is having 11 mm. Okay, simple hole with 11 mm hole. Okay, so here I'll be selecting that and I'll be placing it over here. So this dimension, we don't know exactly where it should be kept, but we know that from hole to another hole it is 92 mm dimension. So from hole to this midline, it should be half of that 92 mm. So this should be 92 divided by 2, which is, sorry, 92 divided by 2, which is 46. So this should be 46, but this should be 92 divided by 92 only, right? 92 divided by 2, which is 46 mm. So once I have this, we can create this with the two methods. Okay, we can rotate it. We can rotate it using rotate option. Like I'll be selecting this, and I'll be selecting this one, and I'll be selecting the center itself. And after that, the step angle I'm going to give 90 degree. This is one method. Here I'll be selecting it, and after that here I'll be creating everywhere like 4 holes I'm creating at the simultaneously. Then after that I'll be finishing it. This is one method. This is one method. Okay, I'll be finishing this hole. So I'll be having the 4 holes which I require. So if I see that 4 holes will be there which are required for me. This is one method. The same thing can be created using the same hole operation. In this, I'll be going once again edit profile option. Instead of this, creating several holes over here using the rotate and step angle method. I'll be selecting this, and I'll be coming back to this return option. Okay, I'll be creating only one hole. Once I create this, okay, I'll be going for the rotate angle. So here what I'm going to do, I'll be going for this mirror option. Also you can use mirror copy feature. I'll be selecting this. This is another method. Okay, this will be creating it. Then after that, this entire thing, this you can rotate it using this pattern method. So I'll be selecting this pattern method. Okay, I'll be selecting this whole option. Okay, and I'll be selecting this pattern option. So here I'll be using pattern smart option. Then I'll be selecting this right profile plane, and here it will be asking how many counts you require and what kind of pattern you require. So I'll be selecting circular pattern, not rectangular pattern. I'll be selecting circular pattern. I'll be selecting this, and I'll be giving radius. I'll be selecting this center of the circle, and I'll be selecting this center of the midpoint, and after that I'll be selecting this center of the circle. Once I select this center of the circle, this will be defining our pitch circle, which is around 46 mm. Okay, for this it is 46 mm. It will ask in which direction you want to create your hole. So here I'll be selecting this. Any one direction you can select. Either it will be creating it from above, or it will be creating at the bottom. From here it will be starting. So I'll be selecting this point, and it will be asking how many count you require. The count, if you want 4, then directly you can select 360-degree sweep. Then after that count could be 4, or else if you want 6 holes, then you can select 6 count. Okay, if you want 8 count, then you can change it to 8 count. See here, spacing is already changed, and it will be showing its spacing from this point, and everywhere it will be showing. If I change it to 8, then it will be, the spacing will be 45 degree. You can see that it will be 45 degree. Then after that you can directly click on this return option. The holes will be created. So this is pattern method. If you want to create a multiple holes from a same hole, then you can go with this pattern method if it is angularly placed. Otherwise, if it is placed in normal regular space, then you have to create 2 holes. Then after that you can directly use mirror option, or else you can create 1 hole, then you can use this pattern option, or else you can create this hole using the what is that rotate option. So I'll be going with this pattern method. Okay, I'll be deleting this mirror hole, and instead of this pattern I have to define this. So I'll be going with this edit definition, and here I'll be going with this uh, don't I have to change it. Okay, so I'll be selecting this edit profile, and here I'll be going to the circular pattern. Instead of this, I'll be making it 4 only. So 4 I'll be selecting, count will be 4. From here we'll be selecting it till this point. So the spacing is 90 degree. You can directly click on this. Earlier pattern has to be deleted. So for this thing, this one I'll be creating it with once again pattern. So I'll be selecting this pattern smart. Then after that I'll be selecting this entire face protrusion. Here I'll be selecting from this circular pattern from this point, the midpoint till the center of the circle. Then count should be 4 only. Okay, so here I'll be selecting it as 4 only. So it will ask in which direction you want. Then after that I'll be selecting return option. So the holes are created now. Once the holes are created, inside this also we have to create a hole which is having dimension of 60 mm. So I'll be selecting this cutout option, or you can use directly hole option only, because you can change it to thread if you want it. So I'll be selecting it over here. From here, I'll be selecting this tool option. Here I'll be selecting 16, and it will be a simple hole, and it will be a throughout hole. Okay, and here I'll be clicking on this return option, and this we are going to have our first gasket. Oh, sorry, the first flange. So once we have this flange, then we can fit the pipe. We can fit this pipe, which is having once again 60 dimension, and it is having M56 thread. So if it is having M56 thread, then this also should be having M56 thread. So to make it, we should be having a hole. The dimension should be 56. This has to be made 56. So for that, we'll be selecting this, and I'll be changing it to 56. And this hole will be a threaded hole, which is having M56 dimension. To hole extent, I'll be selecting, and I'll be creating a M56 hole. So the holes, the name of this hole also will be renamed. We'll be creating it as hole 2. And pattern also we'll be renaming it as pattern 1. So if we use different patterns several times, if I use it, then this will be using cumulative naming. So I have to rename them. Version 1, 2, then hole 1, pattern 1. After that, hole 2. This hole is threaded hole. You can see that in our texture. This will be a threaded hole. You can see that threaded hole over here. Then also it is having its dimension. Now the threading should be given over here in this particular section, and that should be till this point. So 12 plus 6, we should remember, here we should be having 18 thread that will be fitted over here. Now once it is done, we are going to assign material to this from the material table. The material for this one is cast iron, which is CI, which is named as CI. So that's why I'm going to select this cast iron, but I'll be renaming it as CI. Okay, and after that I'll be adding this to library so that I can get that same naming when I'm bringing it in the assembly. So I'll be clicking on this apply to model. Now the cast iron is applied to this model, and the naming also it is successfully named as CI only. And now this has to be saved. Before that I have to go to this file properties, and after that I have to select it in summary, and I have to write it as flange, all the things in capital letters. I will be writing it as flange. Then user, whatever you want to write, you can write it. Then after that this will be saved as flange pipe joint folder, and in this first part will be saved, which is flange, and this has to be saved in isometric mode only. So I'll be saving it once again in isometric mode. Okay, isometric I'll be saving it. If anybody is having any doubt regarding this, you can ask me. You can unmute yourself, you can ask me the doubt, or else if you don't have any doubt regarding anything, then you can leave the meeting. Okay, you can put your attendance in the chat box. You can put your attendance in the chat box, then after that you can leave the meeting. If anybody is having any doubt regarding anything, you can ask me. Otherwise, you can put your attendance in the chat box, and after that you can leave.